I think it would be better if you thought about the world more probabilistically, and I find it common to hear people thinking of events as black or white. If the weather person tells you there is a 40% chance of rain and then it doesn't rain, were they wrong? No, of course not. The 60% happened. If a politician is given a 36% chance to win, and then they do, were the forecasters wrong? No, the 36% happened. You might think, well, then you could never say that these forecasters are wrong. Not true. Instead of thinking, was that forecaster right this one time about that one event? Let's think instead about how often that forecaster is right. Moreover, if the forecaster claims that a thing is 1% likely to happen, how often does the 1% thing happen? It should happen 1% of the time. Not never. Keep in mind, our minds are biased toward remembering times when forecasts are wrong. We tend to talk about and remember them less when they are right. So, I think it would be better to think probabilistically, because most things that happen in the world can be effectively evaluated probabilistically. Let's practice. You're sitting in an airport waiting for a flight. You wonder, how likely is this flight to take off on time? How could we answer that? Well, there are three main types of probability estimation. You probably know classic probability best. It's also, arguably, the least relevant to real-world evaluations. If you have a six-sided die, what is the probability that a single roll will yield a 3? 1/6. Easy, right? That would work for cards, dice, dimes in a bag, etc. That doesn't work in real life. Subjective probability would be basically using your own judgment and reasoning to take your best guess. Humans on their own are pretty bad at this. They'll often be overly confident, change their minds frequently, and not hold themselves accountable to their previous forecasts. Watch sports or political analysts make grandiose claims without flinching, and then fail to revisit them when they were shown to be incorrect. Subjective probability works best when we average the judgments of many experts. And that wouldn't help us with our flight problem at all, since we aren't likely to be able to talk to a bunch of flight data experts. The best approach is probably experimental probability. Essentially, whatever event you're attempting to estimate, look at events like it in the past and see how often each outcome occurred. For our flight example, we can simply look at how often in the past this flight took off on time. Several websites will track flight stats, and a few simple searches will give you a history of a given route at a given time on a given airline. Will it be right every time? Of course not. You'll be more right more often than if you use subjective judgments, though. Sometimes there is no experimental data. Then what? Should you approach your boss to ask for a raise? Here, you are definitely stuck having to use subjective probability approaches to estimate how likely certain events are. A good way to evaluate a situation like this is to brainstorm all of the possible outcomes. Have trusted friends or confidants help brainstorm these because they may think of outcomes you haven't. Then assign each a likelihood value. Make sure they add up to 100%. Again, this doesn't tell you which action to take. It just helps to evaluate how likely each event is to occur. If you're most worried that your boss will think you're out of line and suddenly have a low opinion of you, that particular probability estimate will be more important to you. You might estimate that there is a 5% chance that it is likely to happen and decide that it doesn't really matter what the other 95% is. It's just too risky for you. Here's more. You're deciding whether you should invite a friend to a concert. This friend is flaky. There are three possible outcomes. They say yes, they say no, or they say yes and don't show up at all. How likely are they to say yes and actually follow through? In your estimation, how many times has that happened in the past? That is experimental probability. 30%? Less? Then you know before you even send out that invite that they are 70% likely to fail to attend. Maybe you invite someone else, or you accept your flaky friend for who they are. Other outlier events can occur. You might invite your friend out, they say yes and actually show up, but the concert is cancelled. You might ask your boss for a raise. They get distracted with a phone call, forget why you came into the office, and then run off to another meeting. This will always be true. There are extremely rare events that could completely mess up all of our estimating. I like to remind myself that if I flip a coin, I could get heads, tails, or a comet could smash into the earth and obliterate my coin. Sure, yes, it could, but really, we only want to estimate events that are reasonably likely to happen. We have to accept that certain things are so remote that attempting to measure them and account for them would be futile. I've been a little loosey-goosey with my terminology in here. In the strictest sense, probability values fall between 0 and 1, so it's strictly accurate to say that something has a probability of 0.56, for instance. Through most of this video, I've actually been presenting estimates as a percent chance. For example, there is a 56% chance of rain. That would be equivalent to a probability of 0.56. Odds use fractions, so 1/4, 1 out of 4, would be a probability of 0.25 and a percent chance of 25%. Also, here is a list of some awesome books on this and similar topics and a cool website where you can go to practice forecasting. If you practice these strategies, I bet you'll start being a little more right a little more often.